Alright, let's look at the homework 7.5, 7.6, problem number 13. Alright, so let's do this. Alright, so here we want to minimize this distance formula here, and with the constraint z equals square root of x squared plus y squared. Alright, so first thing I would do is I'm going to square this guy so that I don't have to see square root. So z squared is equal to x squared plus y squared. Right? Then I'm going to just subtract the x squared and the y squared. We get z squared minus x squared minus y squared is equal to 0. So I'm going to call this guy g of x comma y comma z. Right? So let's construct capital F, which is going to be quantity x minus 2 squared plus y squared plus z squared minus lambda. Then you have z squared minus x squared minus y squared. Right? Let's take the partial with respect to x. That will be 2 times x minus 2 and times 1, and let's see, it's going to be plus 2x lambda, right? Set that equal to 0. And a partial with respect to y would be 2y and plus 2y lambda is equal to 0. And then about the partial with respect to z would be 2z and minus 2z lambda is equal to 0. Right? And then partial with respect to lambda, set that equal to 0, always get the constraint. So I'm going to just say z equals square root of x squared plus y squared. Alright? Alright, so let's solve this equation, system of equations. The bottom one, bottom two is probably, these two are easy to work with. So factor out the 2y, right? Then we get the 1 plus lambda and equals to 0. And I'll factor out 2z, then 1 minus lambda equal to 0. Right? So these two actually gives us, let's either y equals 0 or lambda equals negative 1, or z equals 0 or lambda equals 1. Right? So let's look at this. Let's assume that say lambda equals negative 1, right? So which means that the lambda cannot be 1, so it's got to be z equals 0, right? But you can see that if z is 0, then x and y has to be 0 too. So you have one candidate, 0, 0, 0, 0, right? And if you look at the distance, d squared is going to be put 0, so it's a negative 2 squared would be 4, and a 0 squared and 0 squared, so you just get 4, right? Another possibility is, let's say lambda equals 1, right? Then if lambda equals 1, then y has to be 0, right? If lambda is 1, and this equation becomes, right, so you have a 2x minus 4 plus another 2x is equal to 0, which means that the 4x minus 4 equals 0. Factor out 4, x minus 1 equals 0. So which means that x equals 1. Right? So if lambda is 1, x equals 1, and the y has to be 0, and a z is going to be 1 squared plus 0 squared, so it's going to be 1 again. Right? So this d squared is going to be, plugging 1 here, 1 minus 2 negative 1 squared, so it's going to be 1, and the plus 0, y 0, and the z squared would be 1, so it's 2. Right? So you can see that this guy is shorter, so the distance is going to be, take the square root, we get the square root of 2. Right? So the shortest distance is a square root of 2. Let's see if, so it's a square root of 2. Alright, let's go and submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.